Good afternoon, everyone. My presentation today is about chemical characters of disease suppressive and conducive soils of Moller on Shallot and Brebes Central. My research was funded by mandatory research of PNBP ONS year 2021. Shallots are the leading commodity of lowland farmers in Brebes Central, Java. About 30% of shallot production in Indonesia comes from Brebes. In recent years, molar disease caused by Fusarium oxysporum has become an epidemic in the region. I believe that the cultivation practice factors play an important role in this epidemic. The intensity of molar disease varies widely between fields, ranging from very low, less than 5%, to very high, more than 50%. Meaning they are both suppressive and conducive of soils to the disease. My research was conducted in April until May 2021. We covered about 30 farmer shallot fields in this research. These fields come from 7 sub-districts having the largest shallot fields. In this research, we use purposive sampling. We select 30 fields having criteria at least 100 square meter with plants aged 50 to 60 days after planting. From each field, we sample randomly 10 shallot beds. Then we measure the disease intensity with the following formula. Shallot field with disease intensity equal or less than 5% is designated as suppressive file, while shallot field with intensity equal to or more than 50% is designated as conducive field. 3 of each denoted suppressive and conducive fields was selected. About 100 grams of sample soil were taken randomly from each 10 locations, and then the soil was composite. Soil chemical analysis was carried at the Soil Chemistry Laboratory, Faculty of Agriculture, Universitas 11 Maret. We used the test to compare the differences of each value. This picture shows the symptom of the molar disease. You can see here. In the left hand, we can see the healthy plants in the certain field. And on the right hand, we can see that almost all of the plants were dead. In this figure, we can see that the molar disease intensity varied widely from 0, I mean almost 0, to 75%. The average value is 21%, and the standard deviation is also 21%. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of 30 fields have 50% or more disease intensity, showing as conducive soil. While 1, 2, 3, 4, 5, 6 of 30 fields have 5% or less disease intensity, showing as suppressive soil. Almost all of chemical properties taken from disease-suppressive soils were significantly different than of taken from conducive soil. Only N-total percent and cation exchange capacity are not significant difference. The variations in the intensity of molar disease and significant differences in almost all soil chemical characteristics between suppressive and conducive soils indicate a direct or indirect relationship between disease intensity and chemical characters. The quite higher of molar disease intensity may be related with the overall of soil chemical property. You can see here that organic matter, C organic and total is all of them is low. Even CN ratio is very low. Currently, farmers and preppers almost never use organic fertilizers. We know that the organic matter content in the suppressive soils was higher than in the conducive soil. Organic matter provides not only essential proteins but also a complex of micronutrients, improves soil structure, and increase the activity of functional microorganisms. They can play a role in suppressing disease caused by a weak pathogen such as Fusarium. The differences of the intensity of molar disease in suppressive and conducive soils may be correlated with the value of P and K. The P available and K exchangeable in the suppressive soil was significantly higher than in the conducive soil. We know that potassium and phosphate are essential nutrients that play an important role in various physiological and structural processes of plants, including in protecting themselves against abiotic and abiotic environmental stresses. For example, in previous research, a kind of fungi that can increase the availability of P have been shown to suppress the development of molar disease. In another research, the application of 100 kg per hectare of KGL fertilizer on sandy soil can extend the incubation period of the disease and suppress molar disease on shallots by 89%. On vice versa, the deficiency of phosphorus and potassium in garlic has been reported to increase the molar intensity of garlic. As a conclusion, the study shows that the suppressive soil is more fertile than the conducive one. The suppressive soil is chemical characterized by a significant higher organic mineral than those conducive ones.